Okay, so what we did the other day is going to be the case that we usually, we usually go with the probability case, remember, and a variable x would be given to us, and we work with the px. That was the idea that we started. Okay, usually this p of x is a normal distribution, and they ask a probability question, and we change to the z-score and we get the probability. Now the new system is going to be, we are going to be focusing on the characteristic of the group rather than one person. So what we do when the situation is given, we are going to pick a sample of all the sample of the given populations. So we fix a sample size n, and there are many ways to be able to select, for example, n people from a given group. So we are going to consider all the possibilities, all the possible samples. But anytime we pick the sample, we are going to find mean of that sample. Okay, so we are going to have a new variable. That new variable is x bar. So we ask the probability related to this new variable is going to p of x bar. But we usually say what is the probability that the mean is going to be less than 2, probability that the mean is bigger than 2, or the probability that the mean is between 2 and 3. So you got to be careful when they use the expression mean, so you have to use the x bar. The other thing that we have to do, so if you want to do the probability question, of course, you need more information. The information is that if this is normal, because this is the normal that you're going to be interested in. If it's going to be normal distribution, you need the mu and the sigma. So if the mu and the sigma is given to you, you see mu and the sigma is given to you, you can answer the probability question. But what we are interested in, the information would be given regarding the x, not the x bar. So when you have a different information about the x bar, we discussed it the other day that I give you an example. You see the example that we did have a starting player of the basketball teams, and x is going to be their height in inches. So we pick all the possible samples of 2 players. And anytime we pick the sample of 2 players, you find the x bar. So the new variable is going to be the collection of these numbers. So for this collection of these numbers, we evaluate the mean of the original one, means of the 5 players. You see the mean of the 5 player happened to be 80 inches. And then the mean of these samples, which is 10 numbers. But the interesting part was we realized that when we find the mean, they are equal to each other. Okay, so in this situation that we're going to have, this mean of the original one is going to be mu, and the mean of the new one is also going to be mu. But the only difference is the standard deviation. The standard deviation of the original one is sigma, but the new one is sigma over radical n. So what you do with these new problems, when you want to find the z-score, you are going to use this formula. So if you pick one person out, this is the z-score formula. But if you get more than 1 people, if you pick a sample, this is going to be z-score. And then the rest is going to be the same thing that we did before. So we are going to have a new distribution. We call it P of X bar. So officially, I'm going to give a property of this P of X bar. And at the end of the day, just one problem. You can do that, And from now on, we are going to use it. For this section, just one problem. It's going to be usually one problem, 2 parts. Okay, so let's talk about the so-called properties. So what's going to be property of this new distribution? Properties of the distribution of a sample mean. The distribution. Okay, property of the distribution of the sample mean. Of the sample mean. or sample means. So this means P of X bar. Okay, we are going to compare those properties that I talked about the other day. Very important one, the first one. So that is going to be the case. The first thing that we find out the other day is mu of this new distribution, mu of the X bar, is exactly the same as the mu. So this number usually would be given to you, so you can consider it that it's going to be the same mean for the P of X bar. About sigma, which is different. Okay, standard deviation. Sigma X bar. This is going to be a standard deviation of this new one. Is going to be equal to the sigma over radical n. Sigma over radical n. Of course, n is the sample size. N is the sample size, because you are going to pick a sample, so that sample size is going to be n. Okay, so you don't have to find that for the mean, it's the same, but for the sigma, it's going to be sigma over radical n. Now the crucial part is number 2. You can use z-score if you know that your distribution is normal. If your distribution is not normal, you cannot use the z-score. So what's the question? The question is going to be if the original one x is a normally distributed or is a normal distribution. When we go to the X bar, this new one is also normal. So this means we can use the z-score, okay? So this is the first part. If the variable x of the given population is normally distributed, if it's going to be normally distributed with the mean, of course, with the mean mu, with the mean mu and standard deviation and standard deviation, sigma. So if the original one is normal, you see, then that's good one. Then the new one. Then for sample of size n. So this means you are going to go to the P of X bar. For sample of size n, the variable, the new one, the variable mean, the variable X bar is also normally distributed. Normally distributed. Normally distributed. Now what's going to be the mean? With the mean, as we talk about it, the mean is going to be the same. Mu of X bar is going to be exactly like the mu, but the standard deviation is different. And sigma of X bar is equal to the sigma of radical n. Okay, so if the original one is normal, this new one would be also normal. So what would happen to the z-score formula? Because you, at the end of the day, you have to use the z-score formula. So in this case, okay, in this case, z-scores can be computed. Z-score can be Okay, can be, there's a B here. So in this case, the scores can be computed using this formula. Using the following formula. The following, some people, they miss this part. The following formula. So what's the formula this time? Z equal to X bar, because your variable is X bar. X bar minus mu of this quantity. Mu is the same, minus mu. But the sigma is different. It's going to be sigma over radical n. Just make sure don't miss it. Okay, we are not going to, some people, they compute it separately, then they use the formula. No, we just gave the formula right away. Okay, any question? So that's very good. If X is normal, X bar is going to be also normal, so we don't have any difficulty. But what would happen if the original one is not normal? You see, if this is not going to be normal, so how are we going to go to the second one? If it's not going to be normal, remember, you cannot use the score. But this is the one that the statisticians are very proud of. Okay, so number 3, it's a separate section in your book, but we give you all of them together. Number 3, this is the one that they call it central limit theorem. The central limit theorem. You know that in each field there is a important theorem. We call it fundamental theorem, like in calculus. If you have done calculus, fundamental theorem of calculus. We have fundamental theorem of arithmetic, and we have a fundamental theorem of algebra. This is a kind of fundamental theorem of probability. What is this? Look at this one. So I repeat it again. If X is normal, X bar would be normal, then you can use the Z-score. If X is not normal, but the sample size that you pick over here is a large. Large from now on means greater than equal to the 30. Okay, so when we say from now on, the sample size is large, large means greater than equal to 30. If n is going to be greater than equal to 30, then this X bar, the other one is approximately normal, or it's normal. So if the X is going to be normal, we can do it. If it's not normal, you try to pick a sample size which is large enough. Okay, so it can be done, proved nicely, but we need a bit of calculus to be able to prove it. So what's going to be the central limit theorem in this case? So for let's say a relatively large, relative means relative in a statistic. Okay, for a relatively large sample size, you see that size must be bigger than 30, greater than equal to the 30. If it's going to be greater than equal to 30, then the X bar is normal regardless of whatever happened to the X. If this is going to be the case, you see, the variable X bar is approximately normal. It's like a normal. Approximately. Okay, approximately normally, if you like, distributed. Normally distributed. Okay, regardless of whatever X is. We don't care about the X anymore. Okay, so this means regardless, we don't care about the X of the distribution okay, of the variable X, of the variable X. See, it's a great theorem. That's why from now on to the end of the course, all the theorems, all the subjects that we are going to discuss, we are going to discussing about the X bar rather than the X, because we are sure that we have a normal case. Okay, so again, in this case, the formula for the Z square would be the same. So I just emphasize that in this case, all the formulas are satisfied. So this means mu of X bar is going to be again exactly as the mu. So we are not going to change it. And the sigma X bar is going to be sigma over radical N. And your Z score formula and Z score. Okay, Z scores again are going to be computed by using this formula, by using the formula that we talk about it. Z equal to X bar minus mu over sigma over radical. That's it. Great theorem. So the sample size, this is going to be important from now on. You see, you will see for the rest of the course through the end of the course. Always we impose this condition. Is it bigger than 30 or it's going to be less than 30 for future? So if it's going to be bigger than or equal to 30, you are safe. The X bar is going to be normal distributed. If X is originally normal, then X bar is also normal. So basically, you can use the Z formula or the Z square method for all the probability problem from now on. And that's why, that's why we like that normal distribution. Okay, that's it. Any question? So let's check. We're going to check the examples. Okay, it's going to be only one case. So I give you a couple of them, then we go on that practice one. So what's going to be the example? First example. This is a situation. This is, let's say, I go with this one first. I have a couple of them. I can give you two. The average. Okay, the average number of pounds. Number of pounds. Okay, pounds of meat that somebody consume. A person. Okay, a person consumes a year is going to be something like 218.4 pounds. Okay, so that's going to be the mean average or the mean meat consumption for every person in a year, 280. So what's the question? The question is going to be assume this variable of the amount of the meat is it's going to be normal. Okay, assume that, or they go with the standard deviation. Assume that the standard deviation, the standard deviation is 25 pounds. Okay, standard deviation is going to be 25 pounds, and the distribution is normal. Okay, so X is going to be the distribution of the variable X is going to be the distribution of the meat consumption. Okay, the mean is 218.4 and the standard deviation is 25, and this distribution is normal. So what they are going to ask you, they break this problem in two parts. The first part, they pick one person out and ask the question. If they ask a question regarding one person, you are in the population. So you are going to, your distribution would be P of X and the Z score would be the usual formula. Then they change that 1%. They say 10%, 12%, okay? So this is the nature of all these problems. They ask you to find the probability, find the probability that, look at this one, a person, 1%, a person. So a person, if you like, this means the sample size is equal to 1. You see, 1%. Suppose a person, okay, a person is selected randomly. Okay, randomly, that person consumed less than 224, okay, pounds meat per year. See, this is the first part. Find the probability that if we pick a person, okay, a person selected, we don't need the is here. A person selected randomly consumes less than 224 pounds. You see, this basically means, if you like, this means you want to find the probability that X to be less than 224. You see, this is going to be your question, okay, for the first part. Your variable is X because you pick 1% out, okay? Now, they quickly change it in the second part. They ask you the same question, but you are going to tell you, oh, okay, if a sample, okay, sample of 40 people. You see now your sample size, this is going to be your sample size. Your sample size is going to be n equal to the 40. Okay, if a sample of 40 people or individual, okay, individuals or persons is selected, same question, but if it's going to be selected, we would like you to find the probability. Now you are in a group. When you are in a group, you have to talk about the characteristics of the group. Find the probability, that, look at this one now, that the mean of the sample, the mean, okay, mean of the sample, will be, okay, will be less than 224 pounds per year. You see, you want to find the probability that on average, if you like, okay, the probability that on average, that group would consume less than 224 pounds. So for the first part, you want to find it so that a person would consume less than 224. Now you are in a group. You want to know if your group, what is the chance that your group would consumes, on average, would consumes less than 224 pounds. So symbolically, this means you are interested in probability that you see the mean means X bar is going to be less than 224. You see, that's how they describe this type of problems. So for the first one, you pick 1% out, a person. So when it's a person, you are in a population, so n is equal to 1. So the question is going to be probability of the variable X to be less than 224. But in the second part, you go to inside the group. So when you are inside the group, you are going to talk about the average consumption of the group rather than a person. Okay, all the problems are going to be in this format. Any question? So read it carefully. This is the way you are going to analyze it, and quickly you can solve it. Solution of the first part is like a normal distribution, usual one. So you are going to, you are going to note that the first part, it is a normal case. It is a normal distribution. Normal distribution. Remember, anytime you say normal distribution, of course, you have to look for the mean. With the mean is given to you. The mean is equal to, mu is equal to the 218.4. Okay, and the standard deviation of 25 pounds. So what's the question? The question is, what is the probability that X is going to be less than 224? You know that from now on, it's just a usual practice. You have to find the z-score of 224. Okay, find the z-score for X equal to the 224. So the formula is going to be z equal to the X minus mu over sigma. You substitute, your X is 224 minus mu of 218.4 divided by 25. You have to subtract it, simplify it, and use only 2 decimal places. If you use your calculator, this number would be 0.22. Okay, so you change the problem from the X to the Z, so probability that X is going to be less than 224 is equal to the probability that Z to be less than 0.22. Okay, so you go to the Z table and you find it. It's less than, so this is area to the left. You see this is going to be a situation I'm going to have. Remember, this is 0, and the number that you have is a positive number, and this is 0.22. It's less than, so it's area to the left, and area to the left is the one that you can find it directly from the table. Any question? 0.22. So you go to the table and you pick this is going to be 0.2 first. That's a 0.2. 0.22, this is going to be 0, 1, 2. So 0.5871. 0.5871 is going to be the one. Okay, so this would be 0.5871, which is the same as 58.71%. Okay, so probability that somebody would consume less than 224 pounds of meat is going to be almost 59%, 58.71% to get the result. Any question? Of course, you can do this operation, but your calculator, if you do it, I accept it. But only you have to give us the problem. You see, you explain it. If you want to use the calculator, you want to find the probability. So I do the calculator too. So for the calculator, you have to give us those connection and then the calculator. It's like in your test, some of you use that problem. I think I graded, I think 6 or 7 questions. A couple of more I do it today, and then you will see the result. But some of you, for example, use the product rule, but you didn't give us any formula or anything, just the numbers. So you have to get it to this part to see probability of X less than 224 if you want to use the calculator. So you need the mu, which is 218.4, and the sigma of 2.5. You see, to use calculator, whatever you have. Okay, so this is going to be a TI, or just the easiest one. So you go with the second, and there is a variables here, and on the top is distribution. Okay, you click on distribution. Now you see the name of the distribution that we're going to have. The one that we're going to use is going to be normal distribution, but the normal with the CDF, which is number 2 here. So you click number 2, or you bring it down on number 2. On number 2, and then if you click, then you will see it. You will see the lower and the upper. This would be, your result is going to be an interval. You see the interval that you have, get the one that you want to find. The one that you want to find from the interval point of view is going to be something like -∞ and 224. For the -∞ in the calculator using, so this the interval is a -∞ and 224. Okay, this is your interval. In the calculator, -∞ would be denoted by -1e99. For the positive infinity, you go with the positive 1e99. For the -∞, -1e99. You can type it, or sometimes it's there. Okay, so it's going to be lower part of the interval and the upper part would be 2 to 4. Okay, so this is what we have. For the lower one, you already, it's a -1e99, which is a infinity. Okay, and the upper number that I have, okay, I clear this one. What was the upper number that I have is 224, 2 sorry, that's a 224. Then I have to bring the mean. The mean is 218. Okay, the mean is 218.4. That is going to be the mean. And the standard deviation of 25. Okay, standard deviation of 25. Then you go to the base and then you continue. Okay, that's pasted for you and then give you the result. 58.86. 58.86, you know, it's very close to the one that we did. Sometimes a little bit different, but it's fine. Okay, any question? So if you want to do the calculator, we accept it, but you have to give us this information. Okay, write it down. And then the result with the calculator, it's a 86%. We accept both of them. Any question? So it would be easy, you know, to use the calculator if you have it. Okay, if you don't have it, you know, I accept both of them. Okay, and from now on, I do both of them. So you can compare it and you can use either one. There is a cheaper calculator of the, you know, the same thing. It can be done for you. Okay, this is also, I think it's $30, 36, you know, I got this one from Amazon. Almost everything from the statistics for this course can be done with this one too. Okay, so just, you know, if you want, you're interested in this type of technology, get it done. Okay, so that's the first part. Any question? So the first part, size was 1, n was 1, and we're just talking about a person. Now we go to the second part. We have a sample size. Everything would be the same except this x would be x bar. So the formula is not going to be sigma, would be sigma over radical. Just make sure don't miss it. So we go to the second part. In the second part, they ask the same question, but this time they ask what if to check if the mean of the group. So the question now is going to be in the second part. I want to find the, just bring the number so I can do it quickly. So for the second part, we have a sample size. The sample size is equal to the 40. So the question would be given in terms of the mean. What is the probability that x bar to be less than 224? So the situation would be different. Your z-score is going to be different. So you are going to explain that since x is normal, x is normally distributed. When we talk about it, it follows that by the central limits theorem. It follows that x bar is also normal. X bar is also normal, or also normally normal or normally distributed. Okay, so the question is going to be probability of X bar to be less than 224. So your sigma would be different. Okay, you have to find the Z score. Find the Z score. Z score, but for X bar, just explain, you can do it right away. But make sure you use the correct formula using, okay, using this formula. Z equal to, okay, Z equal to the X bar minus mu over sigma over radical N. Okay, your formula would be different. So you are going to check this one. X bar is 224, 224 minus 218.4, 18.4 and divided by 25 and the square root of 40. Okay, because we have a sample size. If you use your calculator, that give you 1.42. So this is it. So you have to find the P of Z to be less than 1.42. It's easy to find. The area to the left. Okay, so the number is 1.42, area to the left, and that would be the exact number from the table. Go with the 1.4 first. You see that's it. This is 1.4, 1.4, 1.42, 1.40, 1, 2. Okay, 1, 2, so that you have 0.92222. Okay, so this is going to be 0.9222, which is 92.2%. 92.22%. So P of X bar, the probability that the group meat consumption is going to be less than 224 is quite a lot. Is a 92.22%. Okay, so when you are in a group, okay, when you are going to be in group, there are more possibilities, more chance that you are going to consume less than 224. But when you talk about the percent, from 1% to the percent, the situation is going to be different. The probability over there was less. You see, the probability for 1% was almost 60%. But when you are in a group, that probability increases to the 92.22%. Okay, because in the average of the group, you get different percent. So different people may have different meat consumption. Any question? So that's going to be one. If you want to use calculator, you have to find the Z here because the Z is going to be different. Okay, so you have to use the Z of the 1.42, and you can use, you know, that would be the same as finding it really. That's not going to be difficult to do that part too. Okay, so go to the second distribution and you get to the number 2 here. That's the number 2. In this case, you are going to use the, if you want to use the Z number, okay, so what you're going to do, you clear this one, Z of 1.42. So the lower one again is going to be the same thing. Sorry, the lower one is going to be that. So I just get back and come back again. Okay, that is the number 2 for the distribution. The lower is just a negative infinity that we did have. The upper is 1.42. If you want to stay with the Z, the mu is 0 and the sigma is 1. They are not going to change it because that would be a standard distribution for the Z. Okay, so you bring it down, you paste it, and you get the number 0.9221, which is 92.2%. Okay, but it's just one reading, really. You can do it with your but anyway, your calculator or the table would give you the results right away and nothing to worry about. Any question? So this is how you deal with the distribution of a sample mean from now on. As I told you, we are going to use it for the rest of the course, but for the time being, this is the only thing you can do. Just
Professor, I have a quick
yes,
question.
yes.
So if we're gonna use the tables for the rest of the course, does that mean that applies for quizzes and tests too?
Of course, with this, yes, you have to use it. Yeah, otherwise you can't do it. You have
Okay,
choices,
sir.
calculator or table. But if you want to use calculator, you have to explain the problem, remember. You have to
Mhm.
explain the problem up to the point that you want to use your calculator. You cannot
Okay.
just give me two numbers, you see, you have to explain it. Especially for this one, you have to get the new z to be able to do it because your variable is going to be x bar. There is a situation that we can use also the x bar with your calculator. Yes, you say with this one page, everything we do for the rest of the course, you need this one. Okay, this or calculator, everything we do. Because all of them would be at the end of the day, it's just a z score. Any question? Make sure everything is clear, you know, to be able to do it. So what I'm going to do is, let's go to that. Let's see how much time do we have. I can give you another one. Yes, I give you this. The next one is interesting. Then I go to the practice one. You see, this was the case that x was normal and the x bar is normal too. But this a new case that I like you to see it is the case that the x is not normal. You see, look at this one. You see the advantage of that central limit theorem on this problem. What's the problem? We talk about average age of vehicles or cars in the United States. The average, average age of, a car or a vehicle registered registered in the United States, US, is 8 years, is 8 years, 8 years or 96 months. Okay, it's something that we know. So this is going to be the average age of the old cars. So what's the question? The question is going to be assume the standard deviation is also. So that's the mean. Okay, assume that the standard deviation deviation is 16 months. 16 months. Okay, so you have the mean, which is a 96, and we have the standard deviation, which is 16. Okay, but nothing talking about the normality, nothing, we don't need. Now, what we want, we pick a sample. If a sample, if a sample of 36 vehicles, 36, vehicle, that's going to be 36 vehicle is selected. 36 is selected. We wanted to find the probability, that, look at this expression, that the mean, the mean of their age, the age of the vehicle, of their age, is going to be between 90 and 100 months. 100 months. See, that's a question. And you know that if you want to change this one into a symbolic form, the mean is x bar. So you want to find the probability that this x bar is going to be between 90, greater than 90, and less than 100. So that's the question. You see, as you can see, there is nothing about normality. You don't have any assumption for your normality to get this one true. Okay, so the solution is going to be, we have a situation with the mean of the mean of 96 months and the standard deviation of the 16, and we have a sample size of the 36. You see, you don't have anything about the x, but this is one, use the central limit theorem. You see, the sample size n equal to 36 is bigger than 30. Okay, so this is going to be the one. We say that note that the sample size n equal to the 36, and this is bigger than 30. So you can assume it. And so x bar, you don't care about the x because you don't need the x in this problem. So x bar is normally distributed, normally distributed. You see, that's the advantage of that theorem that I talked about. So it's going to be normally distributed. So this means this means what? You want to find the probability that x bar is going to be between, x bar is going to be between 90 and 100. You know that you have to find the z-scores. If you don't use your calculator, let's do it first. So we would like to find the, you would like to find the z-scores. So we're going to find the z-scores using this formula. Z equal to x bar minus mu over sigma. Now you have two numbers, start with 90. So call it x1 is equal to the 90. So go find the z-score, call it z1. So z1 is going to be what? X bar. Your x bar is 90 minus mu. Mu is 96 divided by sigma, which is 16 over the sample size of the 36. Sample size of the 36. To simplify it, the top would be -6. And the bottom one would be 16 over 6. 16 over 6. So do the algebra is a -6 times it by the reciprocal of the bottom one, which is going to be 6 over 16. So that gives you -36 over 16. You know that you have to divide it and get the two decimal places. So the z1 would be -2.25. So that would be z1. Any question? Do the z2. So you go with the x2. x2 is equal to the 100. So we are going to find the z2. So to get to the z2, it's x bar minus mu. I repeat the formula for you, sigma over radical n. So now it's going to be 100. 100 minus 96. The bottom is going to be the same, 16 over 6. We get 16 over, I explain it, 36 again, then you simplify it. So now the top is going to be 4 over 16 over 6. 16 over 6, and just do the same thing as we did for the other one. That give you 24 over 16. And if you simplify it, that give 1.5. So the z2 would be 1.5. So now question in terms of the z. Now you have to find this area 2 to 5 less than z less than 1.5. The area between two curves. Two region. So the z number, this is a -2.25, and this is going to be 1.5. The area in between is the one that you are going to be interested in. Any question? So we go to the table, negative 2.25. You go for the negative 2.2 first and move to the right to get to the 5. You see that's a negative 2 point, and that's a negative 2.2. Negative 2.2. Negative 2.2, you need a 5. So 0, 1, 2, 3, 4, 5. 0.0122. 0.0122 for the negative 2.5. Okay, so that gives you, this would be 0.0122. Then you find the 1.5. 1.5 for the positive numbers. You see, that is going to be 1.5, 1.50, which is 9332. So it's going to be 0.9332. But you have to subtract it. Subtract it to get the result. Okay, so if you subtract it, it's a 0.9332 minus a 0.0122. And if you subtract it, the result is going to be 0.9210. It's 92.1%. So the probability that on average, the average of the age would be between 90 months and 100 months is going to be 92.1%. So this means if you look at your car or everybody's car, if you look at everybody's car in the group, there is 92% chance. There is 92% chance that the average age of the car is going to be between 90 and 100 months. It's almost, that 7 years or 8 years that we talk about it. The statistics that was given to you, so just check it with this sample. Any question? If you want to do it with the calculator, the difficulty is the X bar. You see the calculator, there are 2 ways to take care of that X bar because the calculator give you the X. So the only difference is, that when you go to the X bar, the mean would be the same, the 96, but the standard deviation is different. So if you want to go with this part, let me just show you the calculator. Are you done? So if you want to use the calculator, you see this is going to be the way you are going to use your calculator. The question is you want to find the P of X bar to be 90 X bar, and this is going to be 100. So what you're going to do, the mu is going to be the same thing. The mu is 96, but if you want to use the sigma, this is sigma X bar. You have to use the sigma over radical n if you like. So the sigma is 16, radical n is 36. So that gives you what? That gives you 16 over 6, which is 8. Okay, which is 8/3. So when you go to the table, you have to use the 8/3 for the sigma, or you have to change it to the z. Just one of these this option. So this is going to be the calculator. So that's it. I go back to the distribution. Number 2 is the one. You see you need the lower and upper. So the lower and upper in this case is 90 is the lower. So 90 months is the lower. Upper is 100 months. That's going to be 100. Okay, now you got to be careful for the mean. Mean is just the 96 that we did have. 96, but a standard deviation, you have to use that new one that we find it. So the standard deviation is what? Is 8/3. It's going to be 8 divided by 3. Okay, was correct? Yes. 8 divided by 3. So that's it. You paste it. and then you find it. That's 92.096, almost the same thing. Okay, it's a little bit different from what we did. Okay, yes, we did have 91.1. That 92.1, that give you 92, it's 1. If you run that give you the same numbers. Okay, so that same number would be, so it's the same. Mu between 90 and x bar would be 92.1%. Okay, so be careful because your mean would be the same, but your standard deviation would be different. You have to get that in standard deviation and just do it. Okay, again, we accept it, but you have to explain the problem to tell us that you get to the probability and then you find it. Okay, any question? So this would give you better understanding. You see, we didn't have anything about the distribution. We didn't have normality at all. But since the sample size is 36, 36 is bigger than 30, so we say it's the normal and we do it. That's why from now on to the end of the course, we're just using the mean rather than the x. Because when you use the mean, we are quite sure that we are in a normal case. Because if you are not going to be normal case, you cannot solve these problems because you cannot use the z-score. Okay, so pay attention to this one. We're going to do it several times for the rest of the course. Okay, any question? So let's go back to that practice one to give you an idea. It's a very, very nice review, very good one. And all of them would be repeated. You get these 6 questions on your next quiz, on your next test, and something like 5 of those would be given to you on the final. This section that we cover from now on, they are going to be the one that's going to be covered on the final. The distribution, we start with the binomial one, then now it's a normal distribution of a sample mean, and that's just keep going. You don't need anything else from the first part of the course. Okay, so the review. How we're going to do the review? This must be if. Okay, this is the one that I posted for you. So you have it. So the situation is going to be, remember there was a leftover of the binomial that we did. We need this one. Remember I told you that a section of the normal distribution, normal approximation, which is missed in your book. But I check, I find out that you have a set of problems on the web. So it's a 6.6. So I'll talk about it when you get to the 6.6 after your quiz. Okay, so the problem number 1 and the 2 is the warm-up. A situation is the binomial distribution, and they ask for the mean, standard deviation, and the variance. Okay, so let's see. This is going to be practice quiz number 3. The first problem, for the problem of the number 1 and 2, you see this is number 1. The situation is going to be, they tell you that 2% of the automobile carburetor, you see, are defective. Find the mean, you see, find the mean, variance, and the standard deviation of the lot of the 500 carburetors of the car. You see, the situation is binomial, because if you get an automobile carburetor, there are 2 possibilities. Either it's defective or not. So it's a binomial case, probability of success 2%, the sample size 500, you are interested in this rule, okay? So it is going to be, this is the situation that we have. It is a binomial distribution with the following information. That percentage is going to be probability of success, P 2%, which is 0.02. Find the Q, remember, probability of failure. Remember, P plus Q is 100%. So P is 2%, Q would be 1 minus P, which is going to be 98%. So that gives me 98%, which is 0.98, and the sample size 500. So you are interested in what? You are interested in the mean, variance, and the standard deviation for the binomials. We gave you 3 formulas. You can bring any formula to the test. So start with the formula. Formula for the mu was n times p for the binomial distribution. N is 500, p is 2%, 0.02. You multiply them together, 2 times 5 would be 1,000. You have 2 decimal places, so that gives you 10. That's the mean. Sigma squared for the binomial give you this formula, npq. Substitute, n is 500, 0.02, 0.98. The first two you multiplied already 10, 0.98, 9.8 variance. Take the square root, sigma equal to the square root of 9.8. Use your calculator to find it. Okay. What is going to be, should be there 3 something? Okay, a square root of 9.9.8 equal to 3.13. 3.13, and you're done. Any question? There was one section in your book they talk about these 3 quantities, so why not? We give you one, and we are going to use it in future when you come back from your quiz. So that's the first one. Any question? 3 formulas, remember it. 1, 2, 3. The second one is the same thing. We just want to make sure you understand it. Second one. It's reported 90% of adult smokers started smoking before 21 years old. Find the mean. Okay, this is it. Mean, variance, standard deviation. Of what? Of a sample of 200 smokers. It's binomial case because you may smoke or you may not. So the probability that you smoke is 90%. Okay, so same thing. You argue that number 2, you argue that it's a binomial. It is a binomial distribution with the information probability of success 90% if you are a smoker, which is 0.9. Q leftover 10%. 10%, 0.1. N, the sample of how many people? 200. That's it. It's a binomial case and same formula that we talked about it above. Mu, N times P. N is 200. P is 0.9. You multiply them together. Okay, 2 times 9 would be 18, 180. So that would be the mean. Sigma squared, NPQ. NPQ, you already got the first two, 200.9 times a Q, 0.1. Okay, you already got the first two, it's going to be 180 times 0.1, which is 18. Standard deviation, square root of 18. Okay, it must be for something. So that is square root of 18. Oops. It's 424, I think that's one. 424, the final answer. Okay, so it's not going to be a difficult one to find the mean and standard deviation of the binomial distributions. Okay, any question? So that's the first topic. We need this one for that missing sections that we are going to cover it after, the only section that we're going to cover from this chapter after your quiz. Okay, so we are out of the binomial, getting to the normal. In order to get the normal, first thing to do, we need to make sure that we are familiar with the z-score. Okay, so question number 5. It's just reading from the table or calculator. We don't mind, because this is the 3 cases that we are dealing with all the time. Okay, so why not? You one question to see, to make sure that you are reading these tables or using your calculator correctly. Okay, so the situation is you have to graph each region, different regions given to you. Region in between, region to the right, area to the right of the Z number, area to the left. Okay, draw each region, read it from the table. And remember, the table give you area to the left only. Okay, so this is going to be number 3. So let's do it in this order and go with the C first. C, area to the left of the, okay, left of Z equal to 0.45. That's the actual one. Get the region, you have to draw it for us, remember. So it's positive number. So this is, sorry, that's a positive number. So it's kind of 0.45. Area to the left. You know that area to the left is the exact number from the table. 0.45 on the table. 0.4. You see that's a 0.4. 5. 0, 1, 2, 3, 4, 5. 6, 7, 30, like 35, I think, or 36. Okay, so 45 is going to be 67, 36. 67, 36. You change it to the percent. Remember, you are not going to round it. So that would be the area to the left. Any question? If you want to use calculator, you know that this is going to be negative infinity. You see, calculator. For the calculator, this gives you negative infinity up to the z of 0.45. So in the calculator, this would be negative 1e99. 0.45, since it's a z number, it's a standard, mu 0, sigma 1. You see, your calculator, that is going to be the same thing that we did it. Going with the, okay, going to the second distribution, you get the number 2, which is a normal. You see lower is a negative infinity, so we have to type it. It's a negative 1e. This is somewhere is e. Okay, e99, that would be infinity. Then the upper is 0.45. 0.45. You have to, the sigma is 0 in this case, because it's a z. And mu is 0 and the sigma is 1, because it's a standard one. Okay, you paste and you get it. 6, 7, 36. Almost the same. It's exactly the same. Okay, so this is the way we can do it with your calculator. So the calculator would give us the same result. 67.36%. Any question? So that's one reading to the left. Then if you are going to be to the right, so the right one is part B. Okay, part B, right. Right of what? Z equal to negative 1, 2, 2. The other region. It's a negative number, call this one 1.22. It's the area to the right. Remember, the table would give you only area to the left. Since you want to find the area to the right, you have to find the complement. 1 minus. Make sure don't miss it. 1 minus, go to the table, pick 1.22, negative, negative, negative 1, 2 first, negative, negative 1, 2. Okay, this is a negative 1, 2. You need negative 2, 2, 0, 1, 2, 0.1, 1, 2. Okay, it's going to be minus 0.1, 1, 2. Okay, and then you subtract it, that give you what? That give you 8, and that would be 8. I think it will be 8, 8. That gives us the 8. We get the 8, and we get the 8, and the 8. I think that's it. 80, probably 88.88%. The final answer. You can check it with calculator. Okay, if you want to check your calculator, go to the second, then the 2. So it's area to the right. Since it's the right, it's going to be the other way around. Okay, so the calculator would be, so that's the calculator. Area to the right, so you have to check negative 1.22 and the positive infinity 1e99. That would be your calculator. Okay, so the lower is negative 1.22, and the upper is going to be, you have to type 1 second e99, and then the 0, 1 for the mu and the sigma. So you paste it, and then you find it. Oops, probably I missed something here. Sorry, I go to this second again. So oh yeah, I missed this one. It's 1 point. Okay, it's a 1 point. So that was a negative 1.22. 1.22. That's it. Almost the same. 88876. If you round it, that gives you 88.88%. Okay, so with the calculator, that gives you 0.8887. Or just the same thing, 88.88%. You know, but the table is also nice. Give you the result. Okay, any question? Make sure don't miss it. You have to find the complement because the table gives us the area to the left only. The big one is in between. Okay, that's part A. The order must be different. So it's between two numbers, z equal to the negative 2.18 and 1.34. Okay, get the region. So you have a negative number, which is a negative 2.18, and you have a positive number, which is 1.34, the area in between. So you have to go to the table, find these two numbers, and then you subtract it. Okay, and negative 2.8, you go with the negative 2.1 first. Okay, this is negative 2.1. Then 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, which is 0.146, 0.6. Okay, it's going to be 0.0146. Then you get the other side, 134. You go with the 1.3 first, then 4, 0, 1, 2, 3, 4. 0.90, 9099. And then you subtract it. Okay, you subtract 9099 minus 0146 to get these numbers. Okay, so it's going to be 3. That's going to be 3. That's going to be 5, 4. Okay, 4, and this would be 8. Okay, 8. I think it's 8. Okay, so that give you the final answer. Okay, it's going to be 0.9099 minus 0.014646. Yes, it's 0.8953. 0.8953 or 89.50%. Okay, it's going to be area in between, and you can check it with your calculator. Okay. So we give you one. Just make sure that you are ready, or you can read this type of ideas to get the numbers. You know that for our problems now, we just study the problem, we change it to the probability question. You find the z square, it's going to be one of these 3 cases, and you can do it. Okay, I'll give you a break. We come back and we do those. We have 2 cases. Oh, we have the direct one or indirect one. 3 problems, and we finish it. Okay, so 10 minutes. I come back and do it. Okay, so that was the first topic. Okay, just reading these areas. Then the second topic, of course, is going to be the problem. A situation would be given to you. It's going to be, they are going to tell you it's a normal distribution. You can't miss it because it's going to be given. So as soon as they say normal, you look for two numbers, for the mu and the sigma. And there's going to be a question, probability question. You write it down in symbolic form using X. You change it to the Z table, and you're done. Or just using calculator. Okay, so let's check one. There are three here. I do one of them, then I forget time and come back because there are two more topics to talk about it. So the first one is question number 6. You see number 6, the situation is we talking about the weight of the woman weights. It's normally distributed. As soon as they say normal, you look for the mean. You see the mean is given to you. And then you look for the standard deviation, So these three terms, normal, mean, standard deviation. Then there's going to be a question. You see, they pick one out. You see, percentage of 1. Okay, so this is going to be the probability question. You change it and you're done. Okay, so it's going to be number 6 that I'm going to discuss. So it is a normal distribution. Okay, so it is a normal distribution. Just to organize it nicely, if you like to organize it here, distribution with what is the mean. You look for the mean. Mean is given to is 143 pounds. Okay, that's going to be the weight. And the standard deviation sigma of 29. They pick one person out, one woman, and we want to know percentage is probability. What is the probability that weight of that person is between 140, okay, 140 and 211. You see, that is going to be the question. So it's a normal distribution and the numbers in between. So I do it first, and then I tell you how you're going to do it with calculator. So what you are going to do, you have to find the z-score. Okay, find z-scores using the formula z equal to the x minus mu over sigma. We have two numbers, so we call this one, the first one x1, 140. So you go with the z1. It's going to be x 140 minus mu of 143, a standard deviation of 29. You subtract it carefully, -3 over 29. -3 over 29, okay, you can, it's almost 10%, okay. So I'm going to find it. It's going to be 3 divided by 29. Okay, that give me 1.0. You just use the z with 2 decimal places only. So for the 2 decimal places, this is going to be just -0.1. Okay, that would be the z1. Any question? You do the next one. 211. z2. Again, x, this is 211 minus 143 over 29. You subtract it, that gives you 68 over 29. So use your calculator. This is 68 divided by 29. So that gives you 2 point, you see it's going to be 2.344, but 2 decimal places only, 2.34. 2.34. So now question in terms of the z would be what? In terms of the z would be -0.1 less than z less than 234. So it's area in between. If you get the curve, so you have a negative number, which is a -0.1, and you have a positive number, which is 2.34, area in between. You go to the table and you find the number correspond to these two. Negative 0.1, this is going to be negative, okay, negative 0.1, 0.10, 0.8482. This is going to be, okay, 0.4802. That's for negative 0.1. Then 2.34, you go with the 2.3 first, 2.3, 04, okay, 401234, 0.9904, 0.9904. You subtract it and then give it the probability. Okay, so 0.994, and the subtraction is going to be minus 0.4802. And if you subtract it, that will be 2. Okay, 2, that's a 0. And this is 8 out of 9, which is a 1 and 5 point. So the answer is 51.02%. And you're done. Any question? Now, if you want to do it with the calculator, see, if you want to do it with the calculator, you have to give us up to this part. Just give us those information that we have. Okay, so I put it over here, the calculator. For the calculator, you want to find the probability that X is going to be between 140 and 211. You need the mu, which is 143, and the sigma of 29. It's the area in between. There is no infinity part. Okay, so we go to the calculator, the second and the 2. You see that's the lower is 140. So the lower of the 140, then the upper of 211. 211, your mu is 143. 143, and the sigma of 29. Sigma of 29. Paste it and get the result. That's it. 0.5316 or 17. Okay, 53 with the high, but because we're just using 2 decimal places, so that give you almost the same thing. Okay, which is a little bit up or down. It's all right, but depends on the number of the decimal places that you are going to use it. So if you use the calculator, that give you 0.53, okay, 116 or 17. You can double check it, probably. Sometimes I made a mistake when you do this. But this is going to be the result. Okay, we accept it, but give us this information, show that what are you looking for, and then get the calculator, and we accept it right away. Any question? So normal distribution really is going to be an easy case. You have the 3 cases. We usually give you one problem. It's going to be 3 cases, less than, greater than, or in between. So there is one here. If I get time, I come back and I explain it for you. So the number 7 and the number 8 are just a normal distribution again. Okay, that's a 6. And then you have the 7 and 8. If I get time, I come back and do one more for you. I have the answer for all of them. I may post it so that you can check it for yourself. So that's question 1 on the normal distribution. Ready for the next one? The next one is interesting one. It's the other way around, the inverse. Remember those ideas in everyday life? Okay. They give you something, they give you the probability, the percentage. Then you are looking for the Z. So that would be question number 4, or topic number 4. And you have 2 nice one over here. It's got to be, I think it's a 3 and 4. Yes, it's going to be 3 and 4. So let's go with the number 3 to see what's going on. For number 3, so this is the situation that we have. We talk about the membership of a club, a special one, these organizations. So if you want to be a member, you have to take a test, and you must be in the upper 30%, like the police academy that I gave you the other day. So the mean is 115 and the sigma is 12. We want to find the minimum scores that you need in order to be a member of the club. So you get the graph of this information that you have. Okay, so you are going to be in a upper 30%. So this is going to be the curve. Upper 30% is here. So this is the 30%. So you want to find this number. Okay, Z or X, doesn't matter if you call it X naught. So basically what you would like to do is area to the right. So you want to find a number X or X naught such that the probability that X is to the right greater than X naught to be equal to the 30%. Okay, but since our table would give us only the area to the left, you have to switch it into the left because you can't do it with the table. Okay, so equivalently, if you like, you want to find the probability that X to be less than or less than equal to, doesn't matter, X naught to be equal to the 70%, area to the right. 70%, which is the same as 0.7. So you are here now. You see here with the 0.7. Any question? So we get it from the z-score first, then we come back with the x. So the situation that we're going to have is mu is equal to, okay, your mu is equal to the 115, and the sigma is 12. If you want to get it from the z-score, you have to go back to the table. This is the percentage it's given to you. You have to find the z numbers that would give you that 0.7. You see, you go to the table. These are the one percentage. So you look to see what is close to the 0.7. You go to the table, just start somewhere that you start with the 0.7. See the 0.7, 0.7, 0.7. But check, you need 0.70 if you like. Okay, so these are going to be, and you have more here. You see the first time, check this one. That's 0.01, 0.04, etc. So this number seems to be very nice to the 70%. Okay, you can pick this one or you can be more precise. If you check this one and run that gives you 70%. Okay, so these two are going to be the choices. So I go with this one. So the z numbers correspond to this is what? 0.4, 0.5, 52. So if you pick the z to be equal to the 0.52, that would give you the 70% that we're going to be interested in. Okay, any question? So this is how I picked it. Okay, so I picked the 0.5. I went on. I just explained it for you if you want to compare it. So I get to this number, which is 69.85. It's almost 50%. And I check the number on the top. It's 0.2. So a z or z naught, if you like, equal to the 0.2 would give me that 70% that I'm interested in. Any question? And you have to give us the x, not the z. So what is going to be the z formula? Remember, the z is equal to the x minus mu over sigma. So you have the z is a 0.52. 0.52, the X is missing. Mu is 115 and the sigma of 12. A little bit of algebra, cross multiply. If you cross multiply, that gives you X minus 115 is equal to 12 times 0.52. Okay, 12 times 0.52. This one, 12. Okay, 12 times 0.52 would be 624. So that gives me X minus 115 equal to the 624. You add the 115, so X would be 115 plus 6.24. So that gives you 24.121. So it's 121.4, or you may call it 121 really. So you should get almost the score of 121 or 122, it doesn't matter. 122 to be, that's the minimum score that you need to be able to get to this, famous membership of the club. Any question? So the key is the area that you have to use really. That's 30% to the right. The table gives you area to the left to get these numbers. This can be done by calculator very easily. Are you ready to see the calculator? Go back to the position that we had. Okay, you click the distribution. Now in this time, you have to use the inverse. You see, look at this one. We were using number 2, normal CDF. You have a number 3, INV, inverse, invert, inverse normal. So because this is the opposite. So you have to click on number 3. Okay, you click on number 3, you see, that gives you the area, mu equal to the 0, sigma equal to the 1. And you paste it, you get the numbers right away. If you stay with the 0, 1, that gives you Z. But if you want to get the X directly, so we change the mu and the sigma into that. Okay, but area must be area to the left. So the area is 70%, 0.7. That's the area. Okay, that's the area. Then the sigma. Okay, what was the sigma? Sigma is 115. 115. Okay, sigma mu of the 115 and the sigma of 12. Sigma of 12. Then you paste it and then you get it. That's it. 121.29, which is 121. Okay, it's very easy to do it with calculator, but even if you don't have it or if you don't want, you just get the same result. But if you want to do it with the calculator, remember you have to draw that idea, explain it, then pick the numbers. In both cases, it's going to be an easy problem, and it's not going to be a big deal. Okay, so I repeat it again, the calculator, so that you know it. You go to the second. This time you have to go to the inverse normal, number 3. Inverse normal, that gives you the area. Area must be area to the left. If you go with the 30%, you can't do it. Area to the left, okay, the mu is the given one and the sigma. This would give you directly the X. If you stay with the mu equal to the 0, sigma equal to 1, that gives you Z, but you want the X. Okay, the area, the mu and the sigma, and you paste it and you get the result right away. Okay, very good one. Any question? So there are 2 possibilities. I'll give you another one too, so that you get this one, right? So the only part that you may miss is the beginning. 30% is to the right. You can only work with it to the left, so you have to change it to the left. The other similar one is the problem of the warranty. That would be number 4. Number 4, you go to the Best Buy and you buy a CD player. You see CD players. The lifetime of the CD player, okay, they are going to give you the mean is 7.1 years. Okay, so this is going to be your mean because it's a normal distribution, so you have to identify the mean. and the standard deviation is 1.4. 1.4, you're running the company. You want to set the time for the guarantee, the guarantee time, but you don't want to pay many free CD player. So you would like to restrict that region, punishment region, if you like, rewarding one for the customer as small as possible, 2%. So we want to know how long are we going to set the warranty time, okay? So for these problems, see that would be number 4. For number 4, this is a situation we're going to have. For our case, we have a mean, identify the mean because you need it, 7.1, and the sigma of 1.4. You see, for the warranty, this is going to be the case. So this is the time that you made for the warranty, 2 years, 5 years. Now you want to make it as small as possible, 2%. You must check to see where is the 2%. Is it to the right or to the left? You see, since the warranty, if you give you something like 3 years, anything happen during the 2 years, during the periods of the warranty times, you have to pay for it. You see, you find a cell phone. If it's not working tomorrow, you get back to the Best Buy and they replace it for you. But after the 2 years, you are responsible. Okay, so the punishment area for the warranty is here. So you want to make this one as small as possible. How much? 2%. 2%. So now it's area to the left. So this means you have to find this time, find x naught such that, find x naught such that p of x less than x bar, x0 to be 2%, which is 0.02. That's it. Okay, in terms of the z, we can find it and change it. So if you want to use the table, you check, this is area to the left, you don't have to change it. So check 0.02, find the corresponding z numbers. Okay, 0.02, so it must be a negative number, okay, 2%, 0.02. Where is the 0.2? Oh, it's positive side. 0.02 here, sorry, 2%. 2%. Check to see where you start with the 0.2 in the percentage. Okay, in the percentage, you start with the 0.2. Okay, and in fact, 0.02. 0.02, this is 0.403. Okay, 0.02. This is it, 0.02. Pick something smaller, 0.2. Okay, so that's going to be 0.0222221. Good. 1. Very good. We get 0.20, 0.27, 0.2. That's it. You see this one? Is a 0.0202. If you round it, that give you exactly 0.02. Even this one give you the 1. Okay, so it doesn't matter. You can pick either one to get the result. Okay, so negative 2. Okay, so the choice is going to be between these two really. If you run this one up, that give you the result. So it's going to be negative 0.205. Okay, everybody understand? Get it, this one? So that would correspond to there. So the z number that we are going to get is going to be negative 2.05. The z naught or the x. But we need the x. So go to the formula again. X minus mu over sigma. Your z is negative 2.05. Your x is missing, the mu of 7.1. Okay, 7.1. And what else? Over the sigma is going to be 1.4. Cross multiply. So that gives you x minus 7.1 equal to the negative 2.05 times 1.4. Okay, use your calculator to get this number. So it's a 2.05. Okay, what I have is a 2.05 times it by 1.4. So I get 2.87, negative 287. And to get the x, I put it here. So x would be 7.1 minus 2.87. It's going to be almost 4 years. And you subtract it, let's give it 4 something. Okay, so it is going to be minus 7. It's 413. It's 4 years. So you have to set up the guarantee to be 4 years. To be able, to not to give away something like more than 2%. You can check it with your calculator. This can be done very easy because this is exactly the area to the left. Okay, going back to the inverse, the area this time is 2%, 0.02. 0.02 and the mu of, what's the mu? 7.1, 7.1, and the sigma of 1.4. Sigma of 1.4. Paste it, get the result, that's it. 422 with your calculator. What we got is 413, so it's 4 years. In both cases, give you the same answer. Okay, that's it. Any question? So, easy problem. It doesn't matter either the calculator or otherwise, you should be able to find it. So that will take us to the last problem. And the last problem is the one that we talk about it today. Okay, very easy problem. Distribution of a sample mean. Okay, and these are 2 cases. I have to bring that one up because I don't have a copy here. It's the one that I posted. Where is the problem? Yes, it's here. Okay, this is a situation I'm going to have. And this is going to be problem number 9 on that practice one. Okay, let me share this one so that you can see where it is. Let me looking for it. This is the problem number 9. Look at this one. Problem number 9. It's basically, it's going to be a problem 2 parts. We are talking about the height of the men's. It's a normal distribution. 68 inches is going to be, so this is problem number 9. So we have this information that the mean height of the man is 68 inches and the standard deviation of the 3 inches. Okay, so for the first part, they pick 1% out. Look at this one, 1. You see the first part is 1%. It's always the case. You see, this is what you have to note for this problem. In the first case, n is equal to 1, and they ask the probability to be between 67 and 69. In the second part, they give you a sample, n equal to the 16, but they talk about probability of the mean weight. So this is going to be P of X between 67 and 69. This would be P of X bar between 67 and 69. Okay, so be careful about the problem. Okay, so for the first part, we ask the probability to be between 67 and 69. But in the second part, we pick it with a sample of 16. I'll go back to my notebook. So you can't miss it because everything would be given to you in a specific order. So it's a kind of 2 readings from the table. So we are going to take the first part first. Okay. So in part one, the sample size is 1. And the question is probability that X is going to be between 67 and 69. So you have to find the z-scores, okay? And then its area between two curves. So you get the x1 to be equal to the 67, and the z1 is going to be x minus mu over sigma. We substitute, so x is 67 minus mu is 68, and the sigma is 3. So that gives us a negative 1/3. Okay, negative 1/3, you know, that's going to be what? It's going to be negative point, let's say 33 in the 2 decimal places. Then you go with the x2. X2 is 69. So the Z2 is going to be equal to the X2, 69 minus 68 over 3. So that gives 1/3, positive 1/3, which is going to be 0.33. So you want to find the probability that Z is going to be between these two numbers. Okay, of course you can do your calculator right away. We talk about it. So that would be the question. So that's going to be the area. And you have a negative and a positive numbers, negative 0.33 and the positive 0.33 and the area in between. You go to the table, and if you want to use the table, bring in these two numbers, negative 0.33. This is negative 0.3, 33, 0, 1, 2, 3. 0.3707, 0.3707. Then you go for the 0.33 positive, for the 0.3 first. That's a 0.3, 33, 0, 1, 2, 3, 6, 2, 8. I think it's 8 or 9. It's a bit difficult to read this one. I think it's a 9. 0.62. Okay, 0.62993. And then you subtract it to get the final answer. Okay, so it's going to be 0.6293, and this is going to be 0.37. Okay, 3707. And if you subtract it, that give you 852. 25.86%. So probability that the height of one man is going to be between 67 and 69 inches is 25.86%. So that's the first part. And you know, the calculator will give it right away at this level. Any question? So that's the first part, when you pick one person. Now in the second part, we pick a sample, n equal to the 60. If you pick a sample, you talk about probability of the mean height. So 67 less than x bar less than 69. You see, that's the second part. You have to find the z-scores again, but your formula would be different. Okay, you don't care if it is normal, so this would be normal too, which is the case because the sample size is less than 30, but x is already normal. Okay, I just explained that x is normal. I think that was the one, yes, normally distributed. And so is x bar. So you find the z-score, but your formula would be different. Okay, your x1 bar is 67. So your z would be x bar minus mu over sigma over radical n. Make sure you don't miss the radical n here. So the top would be the same. It's going to be 67 minus 68 over the sigma of 3, but over radical n, which is a radical 16. Okay, so the top would be a -1. This is going to be 3 over 4. You flip it, that gives you -4/3. -4/3 is going to be negative what? 1.33. So that gives you x1. You do the x2. x2 bar is going to be 69. So again, z equal to the top would be okay, that's a 68. Did I made a mistake here? Sorry, that was 67. That's a 60. Yes, that's a 67. So it's going to be 69 minus 68. It's going to be a positive over 3 over radical 16. So it's going to be 1/3. It's going to be 4/3, which is 1.33. So now the probability is going to be probability that z is going to be between -1.33 and the positive 1.33. The table, of course, the calculator will take care of all of them right away. So this is going to be -1.33, and this is going to be positive 1.33. So you have to read these numbers from the table. -1.3. You go for the -1.3 first. That's a -1.3. You need 33, 0, 1, 2, 3. 0.0918. That's for -1.33. For the positive 1.33, that's it, 0, 1, 2, 3. So that gives you 0.9082. Okay, that's a 33.9082. Okay, so you subtract it and they give you the result. So you have the 9082 and you subtract it out of 0.918. So that gives you 4,619, which is a 91.64%. So the probability that the mean height of a group of the men is going to be between 67 and 69 age is very high. That is going to be one. See, it's a nice problem. The action that we're going to use in order to get, to get these numbers. You see, as you can see, they are not difficult, but you have to practice to be quick. It takes times if you don't want to use your calculator. Okay, but we don't mind. You can do either one on the test, but explain it. Okay, explain to get these numbers. Okay, what's that? 0.8. Just double check. Check it again. 4. This is going to be 6, 9, 1. I get one. Yes, you are right. 8, 1. That's it. Yes, 81.64%. Okay. So as you can see, I covered 6 topics and 6 questions for the quiz, which is going to be on Tuesday. Okay. Study this one carefully. As I told you, it would be good for your next test and of course for the final. Then when we come back, one more section from this chapter, we cover it, and then there is going to be the second part. Remember, we talked about inferential statistic, something that you're going to predict. You get some information from the sample and you get a prediction for, okay, whole population. It's going to be quite interesting one to see. Okay, that's it. I have to go. Have a good one. If you need anything, email me. Okay, bye-bye.